On to the next section. We have talked about our basic truth table facts. We've done a plethora of truth tables. Now what we're going to do, before we talk about arguments, the very next section we'll get to finally looking at arguments and their validity or whether they're not valid. We're going to talk about, are there ways that statements, whether they have different connectives, can mean the same thing? So that would be called something, that would be called equivalent statements. So two statements are called equivalent. Two statements are called equivalent. The symbol for equivalent in logic is an equal sign with arrows on both ends. Okay, so it's an equal sign with arrows on both ends. So two statements are called equivalent if both have exactly the same truth values in the answer column. So they're called equivalent if they have the exact same truth values in the answer column. Not just the same numbers of trues and falses, but in the exact same rows, okay? Everything is identical, okay? And that would let you know that you have equivalent statements. So what I'm going to let you do just to go through an example of this is an exercise 1. I've given you two statements. I've given you P and in parentheses Q or R. And the other statement is P and Q or P and R. And I would like you to determine using your truth table, are those equivalent or not? So yes or no. The answer is yes or no. Okay, so we've got lots of ors and ands in this problem. So on the left statement, I'm going to get started. I'm going to start with that Q or R statement that's in parentheses. So I've got Q or R. I'm just looking at these two columns right next to each other. And so the or statement is true when either one of them is true. So true or true is true. True or false is true. False or true is true. False or false is false. True or true. True or false, false or true, and then false or false. So we get 3 trues of false, 3 trues of false. And then to complete this statement, I'm going to take P and I'm going to AND it with that column that I just got. So I'm going to take a check mark at P, I'm going to take a check mark at Q or R, and the AND statement is true when both are true. That is the only circumstance. So my first row, I've got true and true, that's good, that's true. I've got true and true, that's true. True, then true, so we're 3 for 3. Uh-oh, true, then false. Now we're false. All the rest of them start with a false, so all the rest of them are going to be false and statements. Up to this point, are we doing okay? Everybody feeling good so far? Okay. I'm going to switch colors just so that there's a distinction. So this column, though, is the one that I will compare. So I'm going to put a cute little asterisk underneath just so that I know that that's the column I'm interested in. That column represents the truth values of the left-hand statement. And when I am done with the right-hand statement, if I see the exact same results, then these are equivalent. If there is any difference at all in any way, then they are not equivalent statements. So here we go. The first parentheses has P and Q. So P and Q, I'm just going to go down the P and the Q column, and I've got true and true, that's true. True and true again is true. All the rest of these, all other 6, involve an F at somewhere, so all of them are going to be false. P and R is the next one. So I'm going to go down the P and I'm going to go down the R column, put a little dot right above them. So true and true again is true. True and false is false. True and true is true. True and false is false. False and true. False, false and false. False, false and true. False, and lastly, false. Am I going too fast? Everybody up to speed? We doing okay? All right, last but not least, what I'm going to do is I'm going to take the P and Q column. I'm going to OR it with the P and R column. So now it's a disjunction with these 2 columns that I'm putting a nice bold pink check mark right above. And so when I OR them, remember either one being true leads to a true disjunction. So true or true is true. True or false is true. False or true is true. All the rest of them are false or false. So the last 5 are all falses. And so then the question, are those 2 columns, those 2 results that I have the asterisks under, are they exactly the same in every way? Yes, there's 3 trues, there's 5 falses. So the answer to this question is yes, those 2 statements are equivalent. They have the same truth value no matter what. All right, well, you pretty much now know everything you need to know for this section. All we're going to do now with whatever time we have left, and if we don't get done today, we'll finish this up on Monday. All we're going to do is we're going to talk about three specific types of equivalences that you can take to the bank. Okay, you don't have to prove these are true. You can just tell me I'm using this equivalence and go to town with it. So the first one is called DeMorgan's law. And I think it was in this class, somebody mentioned the idea of, is there a distributive property for the negation? And I said almost, and I asked if we could table that for the minute. So now is the time we're going to talk about that. DeMorgan's laws is kind of a distributive property. Oops, let me slide this up so everybody can see. Okay, so DeMorgan's laws is kind of a distributive property. So there are 2 situations that this thing called DeMorgan's law, it's named for the mathematician who was foundational in the invention of logic. And so he gets named for these 2 situations of DeMorgan's laws, and I'm just going to show you the first one. What DeMorgan's law says is this statement here, when I have a negation out in front of my parentheses, and notice in parentheses, I either have an and statement or an or. These are the 2 times it applies. It doesn't apply for a conditional or a biconditional statement. Then what you can do is you can distribute the negation, but you have to remember one other thing. So when I take the negation, if I have squiggly p, that's good. My first term is going to be squiggly p. I'm going to leave a little space. I've got squiggly and then q, so that's going to be squiggly q. But here's the other thing you have to show about DeMorgan's law is that you don't leave the connective and when you distribute the squiggly, you flip the connective. It's going to become an or. So when you distribute or looked backwards, when you quote unquote factor out the squiggly, okay, you always flip the connective. So if you wouldn't mind, I'm going to give you 25 seconds. I would like you to propose, following that pattern, what do you think DeMorgan's law looks like for the second situation? Okay, so this is going to be equivalent to, well, I've got a squiggly P. Then what? An and statement. I'm going to flip this connective. Since I'm distributing the squiggly, this or statement is going to become an and then I have squiggly Q. So there's my DeMorgan law. So like I said, you can take that to the bank now. If you're doing a problem and you think it would be a little easier to either distribute the squiggly or to factor it out, you can do that. Just remember to flip the connective. Okay, that is something you can know. What I would like you to do, just again, to do another example of equivalence, this won't take you very long. I would like you to show, you're going to prove something. I know proving is very intimidating, but you have all the tools to do it. You are going to prove one of DeMorgan's laws. So I would like you to tell me or show me using the truth table that these two things are equivalent. All right, so just getting started with this. So for the first one, I've got P or Q. So the or statement is true when either one of them is true. And then I'm going to put the squiggly in front of that. So I'm going to change the truth value. So it's going to be 3 F's and the last one is a T. So that is the left-hand statement. Now the right-hand statement, I need a squiggly P. So P is 2 trues, 2 falses. So we've got 2 falses, 2 trues. I need a squiggly Q. Q is true, false, true, false. So squiggly Q is false, true, false, true. And then last but not least, I'm going to connect those 2 purple columns together with an and. The and is true when both are true. So false and false is false. False and true is false. True and false is false. And last but not least, true and true is true. And you have just demonstrated, you have just proven that these 2 things are equivalent because those columns are the exact same thing. So well done. You're a logician. You're doing great. You're doing great things. Any questions up to this point? All right, so what we're going to do is we're going to now use DeMorgan's law a couple times just to rewrite something in words. Okay, so for instance, exercise 3. I'm gonna guide you through exercise 3, and then I've got a couple of similar things for you, and then we'll evaluate our time, and if I have time to do the next, or if we're just going to wait and finish the rest up on Monday. All right, so here we go. We are going to use DeMorgan's law to write an equivalent statement to this. Okay, so we're going to write a statement that means the same thing under the same conditions as the dog was not a bulldog and the dog was not a boxer. Okay. So first thing I'm going to do now, at some point you can probably do this without defining the simple statements. I understand that once you catch on to what DeMorgan's laws are, you could read this without it. But for my examples, I'm going to go through all the steps so you can see where everything came from. Okay, so the statement P, I'm just reading this from left to right. The first statement I have is the dog was not a bulldog. So statement P is going to be the dog was a bulldog. The second statement is the dog was not a boxer. So my simple statement is going to be the dog was a boxer. From there, what I'm going to do is I'm going to write that statement in symbolic form. So the dog was not a bulldog. That is squiggly P. I'm going to put that squiggly in front of it. I've got an and right there. So and means caret. There's my and statement. And then the dog was not a boxer. So not a boxer is squiggly Q. Have I done anything confounding? That right there, what we just did, that was all section 1. Remember, I told you when we went through that long, boring day of writing lots and lots of stuff down, I said that doing this is going to be part of the problems that you do. Okay, so I have squiggly P and squiggly Q. Now what I'm going to do is what the problem's asked. I am going to use DeMorgan's law to write this as an equivalent statement. So you can see if you compare this to the two DeMorgan's laws we just had, we can now use DeMorgan's law in reverse, meaning I can kind of factor out the squiggly. Okay, so what I'm going to do is I'm going to factor out that squiggly that they both have. This is actually the second statement, the one that you all proposed to me what DeMorgan's law was going to say. When I take the squiggly away from the first term, what am I going to have left of the first term? P. When I take the squiggly away from the second term, what am I going to have left? And then DeMorgan's law, this is the key. What does DeMorgan's law say to do to this caret? Flip it. Becomes an or statement now. And now I'm ready to rewrite my statement in words. Well, I like this because it helps us review another thing from the first day. When I have a squiggly in front of my parentheses, what do I say that means in words? Okay, yes, it is false that, or it is not true that, whatever makes you happy there. So it is false that. And then you write what's in the parentheses. So it is false that P, the dog was a bulldog. Or Q, the dog was a boxer. And there's the exercise. Okay, we took statement in words and logically converted it to something equivalent using DeMorgan's law. Any questions about that? All right, what you're going to do. Again, my goal when we go through class is I just try to give you as many examples of things that you are going to see in the homework. That way you're not confounded or upset at me. So you're going to do the same thing here with exercise 4. Okay, there's a little bit of a twist to it. And so if you get something wrong, remember it's okay to make mistakes. Those are chances for you to learn. So do the same thing with exercise 4, please. Oh, So glad you asked. I put this on here when I made this sheet. I did this intentionally because I don't remember if it was this class or another class, but somebody told me in my math lab, they sometimes use the word but, and what does that mean? So that's why I put this on, because I know I didn't mention it because it just slipped my mind. As far as connectives go, but means the same thing as and. It's a conjunction. Okay, thank you for pointing that out. So reading my statement from left to right, it says the sun is not shining. So my simple statement that goes along with that is the sun is shining. And then but, which we already addressed what that means, it is raining is the next part of it. And so the simple statement is it is raining. Trying to create short statements so that we minimize our writing. Okay, so I will now write that symbolically. So the first part of it is the sun is not shining. So I've got squiggly P. But means the conjunction. So caret. It is raining is Q. So this is very similar to the last problem. But what I made a little adjustment so that we would see an example of is both the statements don't have squigglies like the problem at the bottom of the previous page. So I hope this didn't confound you too much, but again, remember this is an opportunity to learn. So again, I'm going to treat this like a factoring problem. I'm going to factor out the squiggly. When I factor out the squiggly, what's left from the first term? P. Then DeMorgan's law says I'm going to make the and statement into a or. Okay, now here's the different part. So if you didn't get this part, that's okay. When I take the squiggly out of the Q, what's left? Think about arithmetic. What's a negative times a negative in arithmetic? A positive. Same thing for logic. Okay, so when I factor out a squiggly here, what I'm left with is squiggly Q, because if I think about this like multiplication, a negation of a negation, a negative times a negative gives me a positive Q. Okay, it's the same sort of thing. Okay, so if you didn't know that or if you didn't figure that out, remember that is perfectly okay. We're just going through different looks of things you might see. So now the rest of this is I'm going to write in words. So I've got that squiggly out in front. So again, I'm going to say it is false that. P, the sun is shining. Or squiggly Q, it is not raining. All right, so I think we're going to have one more problem for the day, and then we'll be at a very good stopping point. This will exhaust our discussion of DeMorgan's laws, and then we'll have two more equivalences that you can take to the bank, and we'll discuss those when we come back next time. So this is what we're going to finish with today is exercise 5. Same thing that we just did. So I'm just going to get started for time's sake. And then if there's any questions, I can ask them, and then we'll be done for the day. So I'm going to define my simple statements first. So the statement is, it is false that I did not pass the test. So I will make the simple statement, I did pass the test. Or I studied too much. So I studied too much. Okay, those are my two simple statements. Since this starts off with the words, it is false that, that's a squiggly and some parentheses. I did not pass the test will be squiggly P. Or is my disjunction, I studied too much is Q. So here we have the reverse process. That's why I gave this particular problem so that you'd have an experience with this. This is the reverse process where we're going to distribute the negation. So when I distribute the negation, I have a negative times a negative P. What does that turn out to be? Positive. And then I'm going to change the or to an and. That's what DeMorgan's law says. And then I'm going to have a negation or a negative times Q. That's a negative Q. And now I will end the problem by writing that in words. So it starts off with P. I did pass the test. And I did not study too much. And there it is.